So let's begin. And yeah, I just want to say how much I appreciate everyone joining us today, particularly the members of the Oklahoma and Montana FFAs. We're grateful for the support of Tanner Taylor, the president of Oklahoma's FFA, and Gwen Simonuk, the executive director of the FFA from Big Sky Country. And also a big thank you to the USDA and Dr. Jacobs Young and her team for their participation and support. Most important of all, if everyone could please mute your microphones unless you're speaking, that would be great. So now it's my pleasure to introduce Jim Bridenstine, who, before becoming NASA administrator, represented Oklahoma's 1st Congressional District. Jim began his federal service flying E-2C Hawkeyes off of the USS Abraham Lincoln aircraft carrier. The administrator has been a leader in ensuring that NASA supports rural and agricultural schools, as well as tribal colleges and universities. Mr. Administrator, the floor is yours.
Well, thank you, Mike, for that introduction. It is great to be here, and really what we're doing today is re-emphasizing a partnership that has been around for a long time. That partnership, of course, is between NASA and the U.S. Department of Agriculture, and we really thought that bringing together some students from FFA would be a great way to kind of roll out this memorandum of understanding between NASA and the U.S. Department of Agriculture. And I say that because FFA is really a transformational organization. And when I say that, we think about the history of FFA and production agriculture, and we think about what FFA is today. Today, FFA is teaching young people about the state of the art in technology, in the development of technology, in entrepreneurship, of the development of that technology. And so I really thought that having some FFA students join NASA and the U.S. Department of Agriculture in the signing of this memorandum of understanding would be just a great opportunity. And with that, I'll share with you some of the great work NASA is doing as it relates to agriculture. And a lot of people don't hear NASA and think, wow, agriculture, or they think technology, they think space exploration, but not necessarily agriculture. But we do have one division of the Science Mission Directorate at NASA that focuses on earth science. We have a lot of earth science missions that are underway right now that are transforming how we can do ag in the future. And your generation at the FFA, the young folks today that are going through and getting their education and getting prepared to carry the agricultural industry of the future, it is your generation that is really going to benefit from all of these technologies. And the goal would be to take what NASA is developing and commercialize it, so that it can not just transform the United States of America, but transform the world. And NASA has a long history of doing things that are transformational for all of humanity. In fact, right now, I'm talking to you in a camera that's built into my laptop, and that camera was developed for a NASA mission to Mars many, many years ago. I say many, it was 1998, if I have my dates right. But there was a company that said, hey, we could actually use that technology in a cell phone. We want to license that technology from NASA. That company was Nokia. And today, all of us who have, a cell phone have cameras in our cell phones, and we use it to communicate all over the world. So technology is what NASA does. It does absolutely transform the world. And of course, many of you in rural Oklahoma maybe are watching using internet broadband from space. So again, space-based communications were born from this little agency called NASA, and that helps us all stay connected even in the midst of a pandemic. So there's so much more I can say about how NASA has transformed lives, but today we're talking about agriculture, and I want to talk about some specific missions that we are involved in that I think are going to be transformational for your generation, and in fact for generations to come. One of those missions, we are using Landsat 8, which is a satellite that NASA built for the United States Geological Survey, USGS. And that satellite is orbiting the Earth and imaging the Earth all the time in the electro-optical spectrum and getting great data and information. Well, one of the experiments that we did, we partnered with the University of California at Berkeley, and we decided that we wanted to get very accurate, very precision measurements for irrigation so that we can increase crop yields, reduce water usage, and preserve nitrates in the soil. And so this is a technology demonstrator using a mission that was designed basically to help us understand climate and the earth, but now we're applying it to agriculture. And what we've been able to do with this capability is we have been able to partner with a lot of the weather research in California, and we can get very precise what we call evapotranspiration measurements. So evapotranspiration is, think of evaporation from the soil and transpiration from the plants. And all of that puts water vapor into the atmosphere. And by measuring that water vapor, we can make a determination as to how much moisture is in the soil. And then based on the soil type and the type of crop that we're trying to grow, we can actually make very precise irrigation plans that can, in fact, reduce water usage by as much as 25% and at the same time increase crop yields, which is going to be transformational for all of humanity going forward. Now, we're doing this right now as a technology demonstrator with one satellite and a partnership with the University of California at Berkeley. But the future is, I think, that this capability and technology, and just to put it into scale for you, what that enables us to do is we can get those measurements for very precise irrigation planning. We can get those measurements down to basically a quarter of an acre, which is an extremely small area when you talk about how you want to irrigate a field, for example. Down to a quarter of an acre, we can get those very precise irrigation measurements for planning. Now, the challenge that we have right now is that satellite, Landsat 8, has a revisit rate of maybe once every 2 weeks. So if you're going to do very precise irrigation planning, we need to have a more rapid revisit rate. And that's where commercial industry comes in. Take what NASA has done, the technology that we've proven, and commercial industry can go out and they can capitalize. This is where the entrepreneurial efforts of FFA come into play. Private industry and private capital can go out and invest in technologies that take what NASA has proven out and expand it greatly, so that someday when you're working in a field somewhere, you can stand in your field or have a sensor in your field, and you can, based on your geolocation, you can very precise, and the type of soil and the type of plant, you can get a very precise irrigation requirement that you can then meet as somebody involved in production agriculture. So that's an exciting moment where NASA is proving this out. Another capability that we have that we're developing is called EcoStress. EcoStress is an infrared sensor, and it's attached to this little laboratory that some of you might have heard of called the International Space Station. And this infrared sensor, of course, is looking at the Earth, and as the International Space Station orbits the Earth, it's measuring the temperature of plants. And what happens is, and a lot of you know this because you're in FFA, what happens is as a plant becomes stressed because it's not getting enough water, the stomata, how the plant breathes, the stomata closes, and when the stomata closes, what happens is the temperature of the plant goes up. And so we can actually see the stress on a plant weeks ahead of when a human eyeball would be able to detect the stress on a plant. And we can see it from space. Now, again, this is a technology on the International Space Station, but this is another technology that is ripe for privatization, commercialization, to ultimately benefit all of humanity when it comes to the production of agriculture. There's so many others that I'd like to talk about, and maybe when we do the Q&A, I can get into them. One of the other ones that I think is important is GRACE. GRACE is a tool that helps us measure the gravity of the Earth. And a lot of people don't realize it, but the gravity of the Earth is not uniform, and it is constantly changing. And what is making it change? Well, gravity is a direct result of mass in space. So the more the mass, the more the gravity. And what we find is that as water around the Earth moves, we can measure the gravity of the Earth using a satellite called GRACE, 2 satellites as a matter of fact, that are always orbiting the Earth, and they're very close together, orbiting the Earth. But what happens is, as they come up to a mountain range, the lead satellite will get a little bit further ahead of the trailing satellite, and we can measure that with what we call laser detection and ranging. We can measure that one satellite got ahead of the other, and from that we know that the gravity well right there is higher than the gravity well where the trailing satellite is. Bottom line is we can very precisely measure gravity all over the planet, and we see the gravity shifting. And the gravity is shifting really for one reason, and that is, where is the water? And what we've been is use GRACE to predict drought. And now, of course, we're integrated into the Drought Center in Nebraska, and we're using GRACE to predict drought and then mitigate against it ahead of time, which is significant. And in fact, back in I want to say it was 2017, I'm pretty sure it was 2017, we were actually able to inform Uganda that a drought was coming to the nation. And because we knew it was coming, we were able to give them aid ahead of time. And it was in the tune of, $2 million or something like that. I can't remember the precise amount. But had we waited and had a disaster occurred, then the amount of aid that we would have had to provide would have been in the tens of millions of dollars. So here we have a mission that can predict drought, that can help us know how to irrigate, when to irrigate, and we have a mission that can provide vital foreign assistance to nations that need it the most. And then we can actually, by doing that, we can actually prevent the disaster from happening and save American taxpayer dollars. So these are just some of the technologies. There's so many more. I'd love to talk about what we're actually doing in space regarding plant technology. We're trying to grow plants in microgravity using the absolute minimum amount of soil, the absolute minimum amount of water. And we do that because when we go to Mars, we're going to have to take all of our own food with us. Well, it's a lot easier to take something that can grow rather than to take the bulk mass and volume that comes with taking your own food. So we're advancing those technologies right now on the International Space Station, developing plants that can grow with minimum water and minimum soil. So just a lot happening in space as it relates to agriculture, and that's why I'm so excited about this memorandum of understanding. What we're doing with the U.S. Department of Agriculture is we're saying, hey, we need to collaborate in a significant way because the world's population is growing and food security is important. The United States of America is the breadbasket of the world, and we want to make sure that we're able to feed the world like never before. And these are some of the technologies that NASA has developed. And by the way, we developed them for other reasons, but now we're finding out that we can apply them to production agriculture in ways that are significant. We just need to figure out how do we scale it up and make it commercial so that it's available to everybody, And that's really the next big step. So with that, we're excited about signing a memorandum of understanding with the U.S. Department of Agriculture and figuring out how we can benefit the farmers that in the future are going to be responsible for feeding more of the world than ever before. So with that, I am going to introduce somebody from my home state of Oklahoma, Tanner Taylor, who is the president of the Oklahoma FFA. So Tanner, I appreciate you joining us today and appreciate your leadership in the Oklahoma FFA.
Well, thank you, Administrator Bridenstine. We are very glad to be here with you guys today. We greatly appreciate it. We, as an association, we have really focused a lot this year on the fact that agriculture is more than just traditional farming and putting a crop in the ground, and there's more to it than what the average person would think. And so we were really excited to get to join you guys today to talk about this memorandum of understanding between NASA and the USDA. I was talking to my parents and some of the state officers, and we were trying to explain to our parents, why are you talking to NASA? And we were trying to explain that there is a partnership between the USDA and NASA. And so we're super excited to get to talk to you guys to learn a little bit about what that partnership looked like and what NASA does for agriculture here back stateside. So we're super excited to get to ask some of those questions. So thanks.
Awesome. Well, thank you. Thank you so much, Tanner. And I think the next person to talk was gonna be the president of the FFA in Montana. Gwen, I think, is that you?
So actually, yeah, we'll have our state president, Brooke Melhoff. She's on the call, and I'll just let her take it away. Yep.
Okay.
Hello, my name is Brooke Melhoff, and I am the state president this year for Montana FFA. And just kind of to reiterate what the Oklahoma team just said about, we're very, very excited to be here and just really grateful to be part of this experience. Obviously, us in agriculture know the ties and connections between science and technology in agriculture, but it's super, super important to get that kind of information out there. So we're really pleased to see what NASA and the USDA are able to do together, and just really grateful to be able to witness this experience. So, and with that, I think I'm going to let the rest of the Montana state officers introduce themselves too, so we can get to know everybody.
Hi, I'm Bailey Gasvoda. I'm serving as the state first vice president for Montana FFA.
Hello, my name is Kay Van Dyke. I'm serving as a Montana FFA second vice president.
Hello, my name is Gracie Chuk, and I'm serving the Montana FFA as a state reporter this year.
Hi, I'm Gracie Smith, and I'm serving as the Montana FFA State Treasurer this year.
Hi, my name is Max Andrews. I'm the Montana FFA State Sentinel.
Hi, my name is Allison Young, and I'm serving as the Montana FFA State Parliamentarian this year.
Hello, my name is McKenna Quirk, and I'm the Montana FFA State Secretary this year. In my notes, it says that I'm going to be introducing Dr. Jacobs Young, so I can go ahead and move into that if we are ready to do that.
I think that sounds good.
Perfect. So I have a bio here about Dr. Jacobs Young. Dr. Shavonda Jacobs Young has served as the administrator of the U.S. Department of Agriculture's Chief Scientific In-House Research Agency since February of 2014. Previously, Dr. Jacobs Young has served as ARS Associate Administrator for National Programs, where she led the Office of National Programs, which manages the research objectives of the agency, and the Office of International Research Programs, which is responsible for ARS's liaison with its international partners. Prior to moving into her roles at ARS, Dr. Jacobs Young served as the director of the Office of the Chief Scientist at USDA, where she was responsible for facilitating the coordination of scientific leadership across the department to ensure that research supported by and scientific advice provided to the department and external stakeholders were held to the highest standards of intellectual rigor and scientific integrity. She also served as the acting director for the USDA National Institute of Food and Agriculture. Dr. Jacobs Young has also served as a senior policy analyst for agriculture in the White House Office of Science and Technology Policy, where she supported the president's science advisor and others within the executive office of the president on a variety of agricultural scientific activities, and worked across the federal government to improve interagency cooperation and collaboration on high-priority scientific issues. Dr. Shavonda Jacobs Young is a native of Georgia. She holds a Master's of Science and Doctorate in Wood and Paper Science and a Bachelor's of Science in Pulp and Paper Science and Technology from North Carolina State University. She also is a graduate of American University's Executive Leadership and Public Policy Implementation Program. So let's welcome Dr. Jacobs-Young.
Thank you so much, and I assure you my bio is going to be longer than my comments today, and so thank you so much for the introduction. Good afternoon. Thank you to the Montana Future Farmers of America for the introduction. I am pleased to be here with you today and honored to speak alongside Administrator Bridenstine. Sir, good afternoon, and thank you for your comments. Right before this meeting, I was telling a colleague about how much I was looking forward to talking with all of you. And she said, what? She said, NASA and agriculture? And I said, yeah. She said, so what does agriculture have to do with NASA? And the answer is simple. Where there are people, there will be a need for food. And so whether those people are sitting in their apartment here in DC or on the International Space Station, the need will be the same. We all need healthy and nutritious food to sustain ourselves and have the energy to thrive, learn, and innovate. And that's where we scientists come in. And this is what we do every day at USDA and at the Agricultural Research Service. We challenge ourselves each day to innovate and advance the production and protection of food for the nation. Asking ourselves how we can help farmers make data-driven decisions as they sustainably produce crops and animals. How to keep those crops and animals free of diseases and pests, and how to better deliver to farmers the tools they need. Tools like new crop varieties, farming methods, and decision tools built using advancements like machine learning and artificial intelligence to help decide when it's best to plant, harvest, or treat. Information is at the core of our research and our science. As NASA offers a very important perspective for our initiatives, you all know that NASA has a tremendous and well-deserved reputation for looking up and out into the stars. NASA also provides for ARS and others valuable information in their work that looks down from space at Earth, the Earth observations. While orbiting Earth, instruments carried on NASA satellites can see entire regions, river valleys, or mountain ranges at one time. These instruments collect information on temperatures, soil conditions, and vegetation, and supply a wider view of a specific research area, allowing us to compare readings taken at ground level for improved accuracy. We're currently working with NASA, as you've heard, to collect soil moisture readings all around the world to help farmers and ranchers prepare for and reduce the effects of drought and respond to climate variability. We're also working with NASA to measure the depths of snowpacks and mountain watersheds to help water managers predict exactly how much water will be available for farmers to grow crops when that snow melts in the spring. Also, like each of us, NASA scientists and astronauts need to eat. NASA needs controlled environmental technologies that will supply fresh food on transit and surface missions. Fortunately, ARS conducts research on improving crop performance in controlled environment systems. Our initiative in this area is another way NASA and ARS are a perfect match. The result will be yummy microgreens and even fresh fruit for the space station and other mission scientists. ARS has even sent nematodes into the space station for experiments to be sure people can use these beneficial organisms to control pests and diseases when growing food out there in the universe. So when USDA Secretary Sonny Perdue and Administrator Bridenstine signed a new agreement between NASA and USDA earlier this year, they renewed and reinvigorated our long and fruitful partnership to help grow food on Earth and in space. To be successful, we need a plethora of disciplines. For example, engineers, mathematicians, soil scientists, hydrologists, geologists, computer scientists, plant scientists, and many other scientific disciplines. All passionate people with education, desire, and a vision for what's possible. These are people who understand the role science can play in keeping our nation strong. That's why the agreement between USDA and NASA also highlights the need for young people like you and emphasizes how important you are for the future. As a scientist leading an agency of scientists, I would like to encourage each of you to consider joining us in this life of science. Whether with NASA or USDA, that doesn't really matter. You can learn from great people and do important things at either place. Just take the step, pick a science you like and follow that path. See where it takes you, into space, onto a farm in Montana or Oklahoma, or into a USDA lab. Either way, we could certainly use your help. So we still have lots of challenges to meet, and none of us can do this alone. So thank you again, and I'm looking forward to hearing what's on your mind. I'll turn things back to you. Oklahoma, future farmers of America.
Hey everyone, my name is Megan and I'll be leading the moderation for the Q&A today. One thing I would like to do is I'll be recognizing the Oklahoma and the Montana presidents for their first questions. But if you do have a question, please raise your hand in Microsoft Teams here. There's a button, or put your question in the chat and we will be happy to ask the question. So first up, Tanner, if you have any comments or questions, would love to give the floor to you at this point.
Absolutely, thank you. I think I will yield my time to Karsten. Karsten actually had a pretty good question, so I'll give her my time.
Perfect.
Hello, everyone. My name is Karsten, and I'm currently serving as the Northeast Area Vice President for the Oklahoma FFA Association. And whenever I was reading through some of the documents that we were provided, I saw that in the background and purpose, it talks about how there are efforts in order to enhance the performance of crop growing and that they have very broad goals. And so I was just wondering if someone could answer maybe what those specific goals are.
Yeah, well, thank you, Karsten, for that question. From our perspective, and I think Dr. Jacobs-Young hit the nail on the head. What we're trying to do is use space to provide data that ultimately can be used to inform crop production. And I think the goal, of course, is to reduce water usage. Dr. Jacobs-Young in her comments mentioned the snowpack, for example, that turns into eventually it turns into water running down a river that can then be used for irrigation, or it can be used for a reservoir for firefighting, or it can be used to drink. If you're in Los Angeles, for example, you get a lot of your drinking water from the Sierra Nevada mountains. So our goal is really to provide the data and information so that decision makers that are involved in everything from water management to ag production, that they can make good decisions. And some of those decisions are going to be made at the state level, some of those at the national level, and some of those decisions are going to be made at the farm level. Like we want to empower farmers to be able to stand in their fields and know precisely what the irrigation metrics should be, and the goal ultimately is to increase crop yields while utilizing every drop of water that is necessary, and not overwatering, because of course that is what results in the soil, the nitrates specifically, eroding away and reducing crop yields. So what we can do is we can apply data and science to increase crop yields, reduce water usage, preserve nitrates, and benefit all of humanity. Now, our goal today is just to prove that the technology works. Our goal for tomorrow is to scale it up so that it actually is applicable to all of humanity. So those are the big goals, I think.
So thank you. I think that's an awesome question. And, agriculture is a high-tech industry. A lot of people have no idea the technology and innovation that grows into growing our food. If you had to guess, which this is probably not a fair guess for FFA because you probably know this, less than 2% of the population is involved in growing our food. They're feeding not just the United States, but we're feeding, communities around the world. That is only possible because of science and innovation. When we look at the productivity levels, when we look at our ability to use less land to grow more, we think about milk production and all the genetics and genomic studies that have gone into that. So the Agricultural Research Service carries on the original mission of the Department of Agriculture. So USDA was started on the mission that we carry today, and that's really delivering important science and data to the agriculture community. And sometimes we forget about the consumers because we focus a lot on talking about the producers and farmers. We also produce a lot of decision tools for consumers. Anybody ever heard of My Plate? Yes, or the food pyramid. It used to be the pyramid. You know, a lot of the work that the data that goes behind those products are developed in one of our 6 nutrition centers across the country. So we would not only work with farmers and producers, we also work a lot with consumers. And so you guys are really at the beginning of your careers. And so your diet and your nutritional intake is a lot different from mine. And so our My Plates would not look the same. And so a lot of the data that we developed is put into tools that makes it really easy for both consumers and producers to make better data-driven decisions. And so we need all of your help, many disciplines. And so hopefully you guys will stay in agriculture, even if it's in NASA.
Thank you. Next, I'll turn it over to Brooke. Brooke, if you have a question, and again, if please raise your hand or put some questions in the chat so we have some questions to follow up here. Thank you. Brooke, over to you.
Okay, well, we were listening earlier when you were describing all the different technologies that you guys have already equipped and have been utilizing. And so we were just a little bit curious about, other than your previously mentioned research, what other technologies are you guys currently developing or working on, or you're excited about that would have a large impact on the agricultural industry?
Yeah, so I'll give you a couple of examples. I'll go back to what Dr. Jacobs Young talked about with snowpack. So NASA has long been interested in mapping other planets. So we use a technology, LiDAR, laser detection and ranging, and we'll fly an orbiter around the moon, or we'll fly an orbiter around around Mars. And we'll use basically laser detection and ranging. So you're bouncing a laser light off the planet or the moon, and then that laser energy, when it's reflected, there's a time. How much time did it take for a photon to go from the satellite down to the surface of the planet and then back to the satellite? And from that time, you can determine the elevation of the planet, and you can actually very precisely map a planet. Well, now we're using what we've developed for that capability. And by the way, that goes back to the first time we used LiDAR to map a planet was in Apollo 15. So that would have been in the early 1970s. And now we're using that technology to map the Sierra Nevada mountains, for example. And we map the Sierra Nevada mountains with LiDAR when there is no snow. And then after a big snowfall, we map the Sierra Nevada mountains again with LiDAR, and we can very precisely measure what the snowpack is in the Sierra Nevada mountains. Then what we have to do is we have to convert that snowpack into a water equivalent. And so we're getting really good at translating a snowpack into a water equivalent. So the question is, when the snow melts, how much water will there be? How fast will the snow melt? So we use another technology. We use spectroscopy. So spectroscopy is you take light and you split it into all the colors of the rainbow, and then you can very precisely measure, what the contents are that you're looking at. When you take reflected light from, example, the surface of the Earth, you can split it, and then you can see what colors of the rainbow get blocked. And based on what gets blocked, you know what's being absorbed. And based on what's being absorbed, you can make a determination as to the contents of the soil, whether it's of the Earth or another planet. In other words, the chemical makeup of the planet. What's interesting, though, is we can use that same technology to measure the color of snow. And people are like, well, snow, that's white. Well, it's not always white. It's different shades of white. And from using spectroscopy, we can make a determination as to how fast the snow will melt. So now we know, and we're getting really accurate. The color of the snow determines how much sun it's going to absorb, how much energy it's going to absorb from the sun, and then ultimately how fast it's going to melt. And so we can get really precise at how much water there is, where the water is going to go, and ultimately how fast it's going to melt and how fast it's going to materialize. Then water managers that have a really difficult job because they're trying to keep the reservoirs full, keep the land irrigated, make sure people have water to drink, make sure that endangered species are protected. They're providing hydropower for electricity for a whole different group of people. And so these water managers have to make sure that every drop is accounted for. And so there is another perfect example of where NASA technology developed for entirely different purposes is now being applied to planet Earth in a way that's going to transform how we prepare for irrigation. And by the way, it's also going to make sure that we don't have to deplete the aquifers, which are critically important in California and Arizona and other places. Those aquifers take 100 years to replenish themselves, maybe even more. And so we don't want to deplete them. And so we're getting really good. And now, again, a lot of what I'm talking about is technology demonstrated. What we've got to do is we've got to scale it up. We've got to make it available to the public at large, and make the best use of all the technology that NASA has developed. So that's a great question, Karsten. Thank you.
Yeah, one of the there's so many examples I could use. But the one I want to share with you is our new Center of Excellence on Artificial Intelligence. And as you know, working in FFA and throughout your education, that we create data sets, and those data sets are not always meant to talk to one another. And in ARS, we have data on some watersheds that goes back maybe 100 years. Then we have soil data, and we have other data sets, genomic and genetic data. And so the beauty of having that data set, the richness of it, is what we can do with it. And so tools like artificial intelligence allow us to take a systems approach to some of our big challenges. So bringing together these data sets using high performance computing, machine learning, and artificial intelligence, it enables us to make better decisions. Looking at we call it G by E by M, genetics, the environment, and management. So taking all of those factors in play and being able to make a more comprehensive decision. And I think about one of our examples that we've released to the enterprise is GrassCast. And the GrassCast, if your mother or father is in ranching, it gives them a better idea about how much grass they'll have available for grazing in the upcoming year. And then it allows you to plan these other decisions that need to be made around that. And that's just one example, but artificial intelligence is being used across ARS, and we're using other techniques to really be able to shorten the time from identifying a new variety of, say, wheat, corn, blueberry, sweet potato, to be able to shorten the time from discovery to being able to have it into the producer's hands to plant and deliver to the American people. And so there's a lot of high-tech science and equipment and platforms being used in agriculture.
Mm-hmm.
Thank you so much for that. We do have a question now from Dalton Rogers. Dalton, the floor is yours.
Oh, hello, everyone. My name is Dalton Rogers, and I'm currently serving as the Oklahoma State FFA reporter. And we've talked a little bit about crop production in terms of the agreement between the USDA and NASA, and haven't heard a whole lot about when it comes to livestock, because we know there's two sides of production agriculture. We have crops and we have livestock. So is there any specific technologies that are being developed when it comes to livestock?
Dalton, you have to let me know if somebody from my livestock team reached out to you and planted this question today. Our animal researchers are always feeling like the plants get all the attention, and certainly, for us, really being able to have sustainable agricultural production for animal production is very, very important. And I really think about our work in the area of dairy. So we're doing creating a lot of genomic and genetic tools to be able to help producers make better choices. So for example, in the United States, we've tripled the amount of milk production and lowered the number of cows required to do that. And we know that we're constantly working to have a sustainable dairy production. And so that helps us on every round. Most recently trending, probably not trending in your circles, but trending in my circles, is a discovery in Beltsville, Maryland about dealing with the #1 parasite that impacts sheep. And so we've discovered a treatment for that. And so that in itself can help any producer who's raising sheep. And we have, I like to say, about 100,000 animals in ARS. So they're a huge part of our family. And we're constantly looking at ways to be gold standards and role models in how to do sustainable animal production. So yeah, it's a huge part of our work.
And I would second that. From a NASA perspective, we have one specific mission. In fact, this is a mission that's being developed right now by the University of Oklahoma, as a matter of fact. So Dalton, you get bonus points for bringing me around to Oklahoma here. But the mission is called GeoCarb, and what it does is it measures carbon from space. Now we have had at NASA, we've had missions in the past that measure carbon from space, but they're always in low Earth orbit. This was a very unique mission where we put it way out in geostationary orbit, which is the furthest orbit from Earth. And from geostationary orbit, and by the way, we haven't launched it yet, it's under development right now. But from geostationary orbit, we're going to be able to dwell. In other words, it's not just going to pass over this part of the Earth once every 2 weeks, but instead it's going to be able to monitor constantly carbon emissions in a certain region of the Earth. And one of those carbon emissions, of course, is methane. And we're going to be able to make assessments as to the diets that the animals eat, and then make a determination as to how much methane is produced. So I think that's going to be a very interesting kind of sustainable agriculture kind of tool that we're going to have in our arsenal. And so that's just one example. But we're going to be able to use GeoCarb to really focus on having this is a unique area where you have energy companies that want to make sure that they are producing energy cleanly and that they're transporting that energy cleanly through pipelines and other ways. And and of course the challenge is that they want to do it cleanly, because if they don't, they're going to get fined by the EPA. On the other hand, you have environmental organizations that, of course, have a keen interest in clean production, whether it's of energy or agriculture. And so here you have like a really good synergy where you've got energy companies and environmental entities that are actually interested in working together to get missions that are beneficial for both. And NASA is kind of at the center of that, whether it's for ag or for energy production. So I think it's again, we've got to get this thing launched. It's going to be a hosted payload on a commercial communication satellite. So we think about DirecTV or Dish Network. We're going to use that satellite to put a NASA instrument on it, and that instrument is going to be used to measure carbon in the atmosphere, which is, and not just carbon, but all greenhouse gases. I wouldn't say all, but a good number of greenhouse gases that are very relevant to us understanding the Earth better.
Thank you so much for that. We're going to wrap up with our last question here from Grace Smith. Grace, please go ahead and ask your question.
Hi. So I was wondering, how does the USDA and NASA plan on sharing research with farmers across the United States, and how will farmers be able to implement it directly on their operations?
So Grace, I think that's a great question, and the answer is we already are. Many of the tools that we've developed and disseminated are based on the science and the information coming from NASA and ARS working together. A number of the tools that have been commercialized and produced for our resources, for our farmers and producers, are a result of that work, of our partnerships. This agreement, the MOU that we've signed here recently, is a confirmation. It is a restating, a reinvigorating of our partnership. We've been partnering for decades, and so it's just really great to see that both of our leaders have come together and really just committed to continue to support the partnership between our two organizations. We have done tremendous work in this area.
Absolutely. And I would just add that one of the things that we do to try to get as much data and information out to the public as quickly as possible is we partner with universities. and we do it through research institutes. So one that comes to mind right now is the Desert Research Institute, which is headquartered at the University of Nevada at Reno, but it's a collaboration with a lot of different universities, and it includes a lot of different state agencies. And so what they're doing is they're taking what we have learned from Landsat 8 and our measurements of evapotranspiration, and they're taking that, and the next big step is to expand it broader. And of course, when it expands broader, initially it's going to be a lot of public-private partnership kind of things. It's going to be a lot of universities taking what we have already learned and expanding on it, going from basic research to applied science to applied research, and then eventually having those universities enter into public-private partnerships or technology transfer capabilities where the technology can be licensed, and then entrepreneurs can capitalize and take that technology and launch their own constellation. So the goal here is ultimately to grow the ecosystem of technologies that increase ag production, and of course all of the great science that's done at ARS is, which of course is the Agriculture Research Service, which is part of USDA, and of course that's what Dr. Jacobs Young is in charge of. But these technologies that USDA has been advancing for years, and NASA is really in the early stages of trying to apply what we've done in space to ag. I really think there's a bright future for agriculture, and the United States of America is going to lead the world, and we're going to feed more of the world than ever before. But it's not just for us. This is for all of humanity, and that's what NASA is. That's what we do. We benefit humanity. So I just like to, since that was the last question, Megan, maybe I'll say a few closing words and then turn it over to Dr. Jacobs Young.
Yes,
again, and this is directly to Dr. Jacobs Young. We are just so grateful for the partnership, the collaboration. We're so grateful for the great work that USDA and ARS has been doing. And we are extremely proud to have this memorandum of understanding, recommitting both institutions to this long-term endeavor, which is to feed more of the world than ever before. And we look forward to a very long and important collaboration as we move forward in this exciting time. So thank you, Dr. Jacobs Young, for your leadership.
Thank you so much, Administrator Bridenstine, and thank you for including us in this panel today. It is an exciting time every time we have an opportunity to sit down with our future, and that's what is exactly what I think about when I think about FFA. You all are so impressive. I want to challenge you the next time you go to your grocery store or Instacart. I don't know what you're doing in your part of the world. I'm doing a lot of Instacart these days, but if you're walking through your grocery store, I want you to remember the Agriculture Research Service. Many of the vegetables, the produce that you enjoy has been developed in the Agriculture Research Service. I think about lactate-free products. If you look at lactose-free products, Lactate, Roma tomatoes, I think about the Happy Meal at McDonald's, the apples that are now part of the Happy Meal. Yes, I still eat Happy Meals. It's my go-to meal.
Hey, I don't know if you know, but the McRib is back. The McRib.
I saw that. So those fresh apples that are now part of the Happy Meal, that technology was developed in the Agriculture Research Service. The turkeys that you all enjoyed at Thanksgiving was developed, the big breasted turkeys were developed right here in Beltsville, Maryland. And so we've had a lot of impact all over the place. A lot of people have no idea that it's federal science and federal research. And so this opportunity to even go further with NASA, if I could just get them to let me on the next, mission, then all will have been, all worth it. But our partnership can only grow by leaps and bounds. And I'm just so proud of the opportunity to take the best of the best and bring them together and really provide, as Grace asked, and talked about, provide those tools to both consumers and producers. So thank you, and please have us again. I think 45 minutes is not nearly enough time to talk about all the amazing things we'd love to discuss. And so thank you for the opportunity to be with you.
Awesome. Thank you. Well, thank you all for joining us, and we'll look forward to maybe doing it again in the near future.
Yeah, absolutely. Thank you.
Bye-bye.